Alright, question number 2. So you are approaching a particular place on a glide slope of 3.5 degrees. So the glide slope is 3.5 degrees. What height should you be at 2-mile range? It's very easy. What height should you be on at 2 miles range? So the range is given as 2 miles. Remember, for the exam, if it is given miles, it's always the
nautical mile.
Nautical mile. There's no big confusion there. Has to find out height on this 3.5 degree glide slope at 2 nautical mile range. It's quite easy, right?
Yeah.
So if you look at the runway here, extended center line, ECL, right? And then you are 2 nautical miles away.
Yeah.
On a glide path,
3.5 degree
glide slope, right? How will you find out this height? So you can apply 1 in 6 there, because this is kind of a track error, distance to go, you can find the distance off. Only thing is, when you convert it to height, use 1 nautical mile is equal to 6,000 feet conversion approximation. And we know that we end up having a simpler way of doing that. So if I apply 1 in 60, we'll just see that way first. Applying 1 in 60, the track error is equal to distance of
3.5 distance gone
into 60. The equivalent of track error is?
So 3.5 degrees.
3.5 degrees. What is the distance of?
Is equals distance of, we need to calculate basically the height.
The height.
Distance gone? So that will be in nautical mile. Basically height will be in nautical mile.
Nautical mile, yes.
But afterwards we will convert it into feet.
Correct? Yes.
Divided by distance gone is 2 nautical miles.
Yes.
Into 60.
Into 60. Therefore, what is height?
So height is 7 by 60. It is 0.11 nautical miles.
That's right. This height, as you said, is in nautical miles. Correct? This is nautical miles.
Yeah.
Now you have to convert this to feet. So you have 1 nautical mile is equal to 6080 feet. Right? So if I use this equation, in this question you can see that nothing specific like 1 nautical mile is equal to 6,000 feet approximation is not really given. So let's try finding the answer using 1 nautical mile is 6080 feet directly. So what is the answer?
Okay. It's 710.
6080 feet divided by 60, that is 760. 10
feet
approximately. So this height over 3.5 degree glide slope, on a 3.5 degree glide slope over 2 nautical miles has to be 710 degrees. Now let's find this using the approximation. If I use the approximation of 1 nautical mile is approximately 6,000 feet, what is going to be the answer?
That in case it will be into 6,000.
3.5 to 2 is 6,000. That's easy. You can see here. This goes to
660.
60 and 6,000 will reduce to 100, and that is the 100 which you multiply with the glide slope. Remember, 3 degree glide slope is 3 into 100. It is coming from this conversion here. 6,000 by 60 will amount to 100 here. How much is it? 3.5 into 100, which is 35 into 2, which is this is 350, and 350 into 2, which is 700 feet.
Approximately it's going 660.
660? 3.5 into 2 into 6,000 by 60. So 3.5.
Okay, sorry, sir. Into 6,000. I made it somewhere.
That's okay.
3.5 into 2 into 6,000 divided by 60. It's 700,
Right? So what I was trying to tell you is that this is the 100 we are multiplying with. In the normal equation here, when you are on z degree glide slope, then the height in the glide slope will be equal to z into 100 times the range which you are considering. This is over 1 nautical mile. 2 nautical mile, it increases. This 100 is coming from this simplification here. So if you don't take this kind of approximation, you won't reach this equation, because you're taking 6080 straight. It's more like an aircraft frontier calculation, where you don't want all these numbers like 6080 to come up while you calculate, right? Now what happens if I use a trigonometric function here? Tan theta. So So what is tan theta here? Theta is 3.5.
Is 3.5 degrees is equals to h. I need to calculate divide by base is 2 nautical miles into cap. Okay, fine.
So h is equal to h in nautical miles will be 2 into tan 3.5.
3.5.
Let's find out.
It's 0.122.
0.12. Remember?
122 nautical miles.
Nautical miles. Yes.
Multiplied by 6080 will give me 743 feet.
This is the actual answer. 743 feet.
Okay.
Right? Now, what if I use, so you can see here 3 different answers coming up. The most accurate one is 743, but for your navigation exam, they expect you to kind of know the 1 in 60 application directly, because that is what is more useful in the aircraft. So we have 2 different answers where you apply 1 in 60 here. This is 1 in 60 directly. This is 1 in 60 with one more approximation where you take 1 nautical mile at 6,000 feet. This should be used only if this is given in the question.
Okay.
Right? Which is 700 feet. Now you have to initially find the answer using the normal 6080 feet. Find the answer 710 degrees, say 10 feet. If you cannot find this answer, then you think about this one, and you'll have 700 feet in the option for sure, and you can mark that. So basically, your trade has to be between these two. If nothing is mentioned, always go with this. Right? They're not expecting you to kind of do it using trigonometry, but in the event you have some kind of a clash that you cannot find any of these answers, then probably you can try doing it, but it's very unlikely. You'll be getting a clash between over here. But if you're given one in nautical miles 6,000 feet, always do this, not the other one.
Yeah.
Okay, because there are cases where they have given both and they have given this in brackets, which means this should be the answer. So be careful with that. We'll do some questions to understand what I'm trying to say, but you can just copy this. This is how you find out. Otherwise, if this question as such is easy, I was trying to show you that these 3 different methods involved.
Yeah. And that oral also is like that. For 3.5 degrees for 1 nautical mile, it will be 3.5 into 100. So
into
like
100.
350 feet.
That is
So
something
like
which
for
we
2
are
nautical mile, it will be double.
700, double, right? But that we are taking this approximation. Right here in the question. Alright, yes.
So if he only says me that consider 1 nautical mile equals to 6,000, then only I'll have to consider the middle one. Otherwise, 6080 feet.
Do this one first. And if you cannot find this answer in the option, then try considering doing it with this one. But when you have 710, you'll have, if you cannot find 710, mostly you'll have 700 in the option nearby, so you can probably pick that up. In brackets, you can see what height they're given QFE. What is that? QFE? Why is it given? What is
It
QFE?
is from the base, like from the ground only.
QFE is your aerodrome pressure level at the aerodrome reference point. ARP is QFE. So basically they're asking you to find out the height from this particular pressure level. So if in your aircraft altimeter subscale, if you put QFE, then the height shown will be actually the height shown will be more like 743, but then over here we're looking at these heights.
Yeah.
You can read the next question for me, please. Third one.
You are approaching a particular place on runway 28 which has a glide slope of 2.6 degrees. So theta is 2.6 degrees. At what height should be you at 4 miles of range? So it is a kind of similar question.
That's right. 4 nautical miles, you are asked to find out the height.
Yeah.
Right? So you know how to find out directly, right? So how will you find height on the glide slope? H is equal to, on a 2.6 degree glide slope, 1 nautical mile you will be
At 260 feet.
260 feet. So over 4 nautical miles, it's going to be
It's 260 into 4.
into 100.
1040 feet.
1040 feet. This is by using the approximation that 1 nautical mile is equal to
Equals to 6,000 feet.
6,000 feet. There's a very high chance that they would give this in the brackets. Most of these questions, they come up with this particular approximation. Now, if this approximation is not given in the question, then how will you find out?
Yeah. So I'll have to use the 1 in 60 rule.
Yes.
So that is basically the track error is equals to distance off by distance gone into 60. So
That's right.
here my glide slope will act as a track error, and distance off is basically the height, will play the role of height.
That's
and
right.
the distance gone is basically the range, 4 nautical miles of range
Correct.
into 60.
The track error is 2.6, your distance off is your height, distance gone is 4, but that is in nautical miles. into 60. So the immediate answer will be height in nautical miles. So to convert that to feet, while doing the conversion,
Feet.
take 6080 into feet, right? So h is equal to 2.6 degrees into 4 divided by 60, and that is going to give you the answer in nautical miles. So to convert that to feet
Yeah.
by multiplying with
6080.
80. So here we take 1 nautical mile as
6080 feet.
What is the answer?
It is 1053
105
feet. 3 feet. Feet. 53.86.
0.8 feet, 1054 feet. You can see there is some
Yeah.
amount of difference, right? 1040 feet, this is 40 feet difference. But as far as
Yeah.
the exam answers is concerned, look at the options and try to find out. Mostly, if this is not given, you have to follow this method. But greater chances that they will give you this one. If that is the case, it's easy, you can just find out straight by multiplying. I hope you understood how this 100 came up, because you're doing the approximation of 6000 by 60, and that is 100. So you can see this amounts to be 100, and what you have is 2.6,
Yeah.
and the rest is 4.
6 and 4.
That's all.
4, yeah.
Right? Yes. Easy.
So you are approaching Paris or at a particular place on a glide slope of 3 degrees. At what height you should be at a range of 2 nautical miles? So it is the same, like
Similar type
600
of
feet.
question, right?
Yeah.
So 3 degree glide slope. You have to find out range of 2 nautical miles. What is the range?
It's 2 nautical miles.
That's right.
So yeah, so the total height should be 600 feet.
That's it. 600 feet. So your glide path is
Yeah.
3 degrees, and range is given as 2 nautical miles. Height in the glide slope will be 3 into 2 into 100, 3 to 100, which is per nautical
Yeah.
mile. For 2 nautical miles, it's going to be 600 feet, and here we take the approximation
With approximation.
with approximation.
With 1 nautical mile considering equals to 6,000 feet.
Remember the previous question, a runway was given, runway 28. What was that?
Yeah. The heading might be the heading of the aircraft, like
It should be 28, but what is the user's information? There is no big use, don't worry. It's just given in the question, right? Alright, so
yeah.
what is it without approximation? So we can find out.
it is 3 degrees equals to
Yeah.
yeah. So it is 3 degree equals to distance of, that is basically the height,
Mhm.
divided by the range is 2 nautical miles multiplied by 60.
60.
So h is basically now in nautical miles.
Yeah.
So it is 3 into 2 divided by 60.
Yeah.
0.1 multiplied by 6080 feet.
Okay.
For accurate, so it is 608 feet.
608 feet.
Is a considering 1 nautical mile equals to 6080.
That's right. Very good. So easy. Not very difficult. Understanding the height and glide slope, it's practically also helpful. And for example, so they do ask, even for ATPLs, they ask such kind of very simple questions. It's not very difficult.